Hello students, in this class we will learn transpose of a matrix. Okay. Then some properties related with transpose of a matrix. Okay. So let us study what do you mean by transpose of a matrix. Transpose of a matrix is the matrix formed when we convert the rows or columns of a matrix into columns or rows. That is, if A is a matrix in the form 2, 3, 5, 6, 7, 9, then A transpose, that is A to the power t, small t, or A to the power capital T is equals to 2, 3, 5, 6, 7, 9 whole to the power t equals to 2, 3, 5, that is first row becomes the first column, and 6, 7, 9, that is second row becomes the second column. Or you can say this first column becomes the first row, this second column becomes the second row, this third column becomes the third row. Okay, that is why transpose of a matrix is the matrix formed when we convert the rows or columns of a matrix into columns or rows. That means if we convert the rows of a matrix into columns or columns of that matrix into rows, then we get transpose of that matrix. Okay, here A to the power small t or A to the power capital T are the notation of transpose of matrix A. Similarly, if B is a matrix in the form 3, 7, 5, minus 1, 2, minus 4, 6, 8, 10, then B transpose is equals to 3, 7, 5, minus 1, 2, minus 4, 6, 8, 10 whole to the power transpose is equals to, this first row will be the first column, the second row will be the second column, and this third row will be the third column. Thus, we can find the transpose of a matrix. Okay. We will learn properties of transpose of a matrix. Okay. Number 1. A transpose whole transpose is equals to matrix A. Let matrix A is equals to 2, 3, 5, 7, 8, 9, 6, minus 2, 4. So therefore, A transpose is equals to, this first row will be first column, this second row will be the second column, and this third row will be the third column. Now, transpose of this A transpose is equals to, this first row will be the first column, this second row will be the second column, and this third row will be the third column. Okay, so A transpose of A transpose is 2 3 5 2 3 5 7 8 9 7 8 9 6 minus 2 4 6 minus 2 4. That is, this is equals to matrix A. That is why in property 1 we can say transpose of A transpose is equals to matrix A. Okay. In property 2, if A and B are two matrices where addition is possible, that means the order of these two matrices A and B are same. Okay. If A plus B whole transpose, then we can write it as A transpose plus B transpose. That means A plus B whole transpose can be written as A transpose plus B transpose. Let matrix B is equals to minus 2, 5, 1, 6, minus 3, 4, 10, 2, 0. So, A and B both are square matrix of order 3. That is why addition is possible between these two matrices. 3, 8, minus 2, 5, 9, 4. This is A matrix plus B matrix is minus 2, 6, 10, 5, minus 3, 2, 1, 4, 0. We can add same positional elements. Plus 2 minus 2 will give 0. 3 plus 5 will give 8. 5 plus 1 will give 6. 7 plus 6 will give 13. 8 minus 3 will give 5. 9 plus 4 will give 13. 6 plus 10 will give 16. Minus 2 plus 2 will give 0. And 4 plus 0 will give 4. So, A plus B whole transpose is equals to 0, 8, 6, 13, 5, 13, 16, 0, 4. Therefore, A plus B whole transpose is equals to, along first column 0, 8, 6, along second column 13, 5, 13, along second column 16, along third column 16, 0, 4. 0, 8, 6 along first column, 13, 5, 13 along second column, 16, 0, 4 along third column. Now, A transpose plus B transpose. Transpose of this matrix A, 2, 3, 5 along first column, 7, 8, 9 along second column, 6, minus 2, 4 along third column, plus transpose of this matrix B along first column, minus 2, 5, 1 along second column, 6, minus 3, 4 along third column, 10, 2, 0. Addition of these two matrices will give 0, 7 plus 6, 13, 6 plus 10, 16. 3 plus 5, 8. 8 minus 3 will give 5. Minus 2 plus 2 will give 0. 5 plus 1, 6. 9 plus 4, 13. 4 plus 0, 4. This is same with A plus B whole transpose. Okay, that is why we can say A plus B whole transpose is equals to A transpose plus B transpose. In property 3, C into matrix A whole transpose equals to C into A transpose, where C is a scalar, that is C is a real number. That means C belongs to R. CA is equals to C into matrix A. Matrix A is 276 along first column, 3, 8 minus 2 along second column, 5, 9, 4 along third column. When we have to multiply a matrix by a scalar, then we have to multiply all the elements of that matrix by that scalar. So this will give 2C, 3C, 5C, 7C, 8C, 9C, 6C minus 2C, 4C. So CA whole transpose is equals to this first row will be the first column. The second row will be the second column. This third row will be the third column. In this matrix, all the elements are multiplied with the scalar C. That is why we can take C as the common factor from all the elements. So after taking C as the common factor, the resulting matrix becomes along first column 2, 3, 5, 7, 8, 9 along second column, 6 minus 2, 4 along third column. So this matrix is the transpose of this matrix A. That is why we can write this is equals to C into A transpose. So CA whole transpose will give C into A transpose, where C is a scalar. That means C is a real number. That is why we can say C belongs to R. Okay. So this is property 3. Property 4. AB whole transpose is equals to B transpose into A transpose. If A and B are two matrices such that matrix multiplication is possible between them, then we can write A B whole transpose is equals to B transpose into A transpose. Okay, so let us check this property holds for two different matrices. Now AB is equals to 2, 7, 6 along first column for matrix A, 3, 8 minus 2, 5, 9, 4 into minus 2, 6, 10 along first column for matrix B, 5 minus 3, 2 along second column, 1, 4, 0 along third column. Here we will apply row by column method for multiplication of these two matrices. Since these two matrices are square matrix of order 3, that is why we can multiply A matrix by B matrix and also B matrix by A matrix. Okay, So let us multiply matrix A by matrix B. Minus 4 plus 18 plus 50. Minus 4 plus 18 plus 50. Then first row by second column. 10 minus 9 plus 10. Then first row by third column. 2 plus 12 plus 0. Then second row by first column. Minus 14 plus 48 plus 90. Second row by second column. 35 minus 24 plus 18. Second row by third column. 7 plus 32 plus 0. Then third row by first column. Minus 12 plus 40. Third row by second column. 30 plus 6 plus 8. Third row by third column. 6 minus 8 plus 0. This will give 64, 11, 14, 124, 29, 39, 16, 44 minus 2. Therefore, AB whole transpose is equals to, along first column 64, 11, 14, along second column 124, 29, 39, along third column 16, 44 minus 2. Okay, so this is AB whole transpose. Now B transpose into A transpose equals to transpose of this matrix A along first column 2, 3, 5, 7, 8, 9 along second column, 6 minus 2, 4 along third column. Transpose, this is B transpose, that means transpose of this matrix B along first column minus 2, 5, 1, along second column 6, minus 3, 4, along third column 10, 2, 0 into transpose of this matrix A along first column 2, 3, 5, along second column 7, 8, 9, along third column 6, minus 2, 4. Same as previous, we will follow row by column method for multiplication of these two matrices. Minus 4 plus 18 plus 50. First row by second column. Minus 14 plus 48 plus 90. First row by third column. that is minus 12 plus 40. Then second row by first column, 10 minus 9 plus 10. Second row by second column, 35 minus 24 plus 18. Second row by third column, that is 30 plus 6 plus 8. Then this third row by first column, that is 2 plus 12 plus 0. Third row by second column, this is 7 plus 32 plus 0. Third row by third column, that is 6 minus 8 plus 0. This will give 64, 124, 16, 11, 29, 44, 14, 39 minus 2. That is, B transpose into A transpose is equals to, along first column 64, 11, 14, along second column 124, 29, 39, along third column 16, 44 minus 2, which is same as AB whole transpose. This is equals to B transpose into A transpose. So, if A and B are two matrices where multiplication is possible, then we can write AB whole transpose is equals to B transpose into A transpose. Okay. So, these are the four special properties of transpose of matrices. Okay. Now, we will apply this property to solve some numericals. Okay. Here we choose a problem. If matrix A equals to, along first column 1 4 minus 3, along second column minus 2 0 2, along third column 3 minus 5 4, then we have to find B, that is matrix B, when 2A transpose plus 3B is equals to 4I3. Here A is a square matrix of order 3 and I3 represents identity matrix of order 3. Okay. Solution. Since matrix A equals to 1 4 minus 3 minus 2 0 2, 3 minus 5 4, therefore A transpose is equals to, this first row will be the first column 1 minus 2 3. The second row will be the second column 4 0 minus 5. This third row will be the third column. Okay. So this imply twice of A transpose is equals to 2 into this matrix. That means we have to multiply all the elements of this matrix by 2. This will give 2 minus 4 6 along first column, 8 0 minus 10 along second column, minus 6 4 8 along third column. Okay. Now 2A transpose plus 3B equals to 4I3. imply 2A transpose means 2 minus 4 6 along first column, 8 0 minus 10 along second column, minus 6 4 8 along third column, plus 3B equals to 4 into I3 means identity matrix of order 3, 1 0 0 0 1 0 0 0 1. This imply 3B is equals to 4 into this identity matrix will give 4 0 0 0 4 0 0 0 4 minus of this matrix 2 8 minus 6 minus 4 0 4 6 minus 10 8. This imply 3B is equals to, we have to subtract same positional elements, 4 minus 2 2, 0 minus 8 minus 8, 0 minus of minus 6 that is plus 6, 0 minus of minus 4 that is plus 4, 4 minus 0 that is 4, 0 minus 4 that is minus 4, 0 minus 6 that is minus 6, 0 minus of minus 10 that is plus 10, 4 minus 8 that is minus 4. This will give B is equals to 1 by 3 into 2 minus 8 6 4 4 minus 4 minus 6 10 minus 4. This imply B equals to, we have to multiply all the elements of this matrix by 1 by 3. This will give 2 by 3, 4 by 3 minus 2 along first column, minus 8 by 3, 4 by 3, 10 by 3 along second column, 6 by 3, that is 2 minus 4 by 3 minus 4 by 3 along third column. So, this is the value of matrix B. This is the way by which we can find an unknown matrix. Okay, when matrix A is given and this relation is also given. Okay.